Hi everyone, welcome to one more of Mrs. John's lesson. Today's lesson is to do with the introduction of energy. So we finished the previous topic on forces. I know you haven't done your test, but you have done your assignment and I've given you a revision sheet and you've had a day's break yesterday with no physics. And today's lesson, it's this booklet. We had them all ready and printed, but I haven't been able to reach that to you. And hopefully when we are back at school, I'll be able to give you these booklets. But I have put the PDF copies of this. It's a very thin booklet. There aren't many pages. And this is actually the last part of mechanics. Okay, so I'll just give you an introduction and just tell you what's covered in today's lesson as well as Friday's lesson, tomorrow's lesson. So what is energy? Energy is the capacity to do work. That is how we define energy. So I'm just going to write that down. So just the simple points. So energy, instead of the word capacity, you can also use the word ability. So anything that can do work has got energy. It has to have energy. So can you imagine if you haven't eaten any food and you're really hungry, you're going to have very low energy levels. And if someone with very low energy is asked to jump up and down, you'd just be doing like just little movements. But if you've got lots and lots of energy, you're full of energy, you'll be like bouncing up and down all over the place, right? Okay, so energy is the ability to do work. It's a capacity to do work. Anything that has energy can do work. Anything that does work has energy. So back and forth. Okay, so the unit in which energy is measured is a unit called joules. So energy is measured in joules. Now if you're writing the whole word, they're all in the lower case. Okay, because it's named after a person, Joule, but this is not a surname. It's just the unit named after the person. But if you're using just the symbol for the unit, then you just write it in capitals. Now, in some questions, you might find numbers like the kilojoule. So I'm just going to tell you what 1 kilojoule is. 1 kilojoule is actually 1,000 joules. Okay, so this is useful information for you to know. Okay, so you've probably done energy in previous lessons, so I'm just going to go through different types of energy. So there are all forms of energy. So to name a few, there's light is a form of energy, heat is a form of energy. If you're running, you've got energy because of movement. We call that kinetic energy. If you're talking like I'm doing, that's sound energy. So these energy forms that I've just listed, heat, light, sound, and movement, they're all what we call active forms of energy because you can actually see or hear something. Okay, something's happening. But there's also other forms of energy which aren't really visible because they are stored. And these forms of energy are called potential energy. So there's two forms. All these energy can be categorized into two. So there's active energy. And this active energy comes in the form of heat, light, sound, and movement. Now this energy because of movement is what we call kinetic energy, and we're going to be learning a little more about kinetic energy in a bit. Now the other form of energy, which is not active, is called stored energy, and the stored energy is also called potential energy. You know, when you say someone has a great potential, so it's there, it's all hidden in you. All of you've got great potentials and you're going to do great things in life, right? So that's potential energy. It's all there. We just have to bring it out. Okay, so potential energy, there are lots and lots of these forms. So one of the common ones that we're going to be learning about this year a little more is what's called gravitational potential energy. And gravitational potential energy is, you know about gravity, it pulls everything down, right? We learned about forces. So if you do anything, in order to lift something up to a height, it takes an amount of force to bring it up. So things gain gravitational potential energy when they're thrown up in the air or they're lifted up. If you're climbing staircases and going to a higher flow, you gain gravitational potential energy, okay? And then there is what's called elastic potential energy. So anything that can be stretched. So we learned there's tension force. That's a force. Now force and energy are two different things, right? So any rubber bands, strings, springs that are either stretched or compressed store energy in the form of elastic potential energy. Okay, then you also have electrical energy. You've got, these are all potential energy. Then any sort of fuel or food, anything that can be burnt, even a piece of wood in your fireplace. These days it's cold, so some people use fireplaces to keep themselves warm. So anything that can be burnt and they produce that heat, okay, they have energy in the form of chemical potential energy. So all food, all fuels, they all have chemical potential energy. And then there's a whole host of other potential energies, but I'm just naming a few. Okay, now there is what's called the law of conservation of energy. So I'm just going to wrap this out. So my board is really tiny, so I can't fit a whole lot in here. But you can always go pause and rewind the video if you want to go and look at something, what I've said earlier. So this one's really important. And this is called the law of conservation of energy. Okay, now what does the word to conserve mean? The word conserve means to keep, to hold, and not to lose. So that's the meaning of the word conserve. Now, the law of conservation of energy, when you're stating a law, you actually have to say it correctly, use the correct words. It says that energy can neither be created nor destroyed. It can only be changed from one form to the other. Okay, so that's what the law of conservation of energy says. Energy can neither be created, you can't make energy, neither can you just kill energy, not destroyed. Okay, but what can happen to it? It can only be transformed. Now the word transform means change from one form to another. So an example of this, so I'm going to put this like this because it's a coat. An example of this is if you throw something up into the air, okay, when you're throwing it up, it's gaining gravitational potential energy and you know it's slowing down, so it's losing kinetic energy. But when you drop it down, it's losing gravitational potential energy and it's gaining kinetic energy, because as something falls, it gets faster and faster. It's accelerating down, right? And then another example is, if you have, I don't have any here with me at home. We have some in school. We've got a whole lot of these little wind-up toys. You know, what you get at McDonald's when you go for a little Happy Meal. Little children get that. So you wind the toy up and then you let it go and it's moving, right? So when you're winding it up, it's actually a spring that you're winding up. And so the spring uncoils. So when you're winding up the spring, the energy that's stored is elastic potential energy because you're tightening up a spring. And then that's converted to kinetic energy. Now, when something moves, in all energy transformations, some energy is always lost in the form of heat, and it's due to friction. Friction is a force, heat is an energy. So in all energy transformations, the total energy is the same, but all of one form may not be converted to just one other form. There might be two other forms or three other forms. You could have some sound, you could have some heat, and so on. So this is my first lesson. Types of energy, law of conservation of energy, and what energy is. And I hope that made sense. Bye for now.